Now, we finished section 2.5, which I know we spent a few days on, which was focusing on proving things about segments. This section, we want to start proving things about angles. We've focused a lot already on the idea of congruence with segments, so this is just kind of bridging that gap right over to congruence with angles. So we've talked about equality with angles before too, so it's not like the idea of angle proofs is new, it's just that we're adding in the whole idea of congruence. We have a new theorem, and this is theorem 2.2 in your textbook, but again, we would never just call it theorem 2.2. And it deals with the properties of angle congruence. And there's 3 parts to this theorem. And it just says that angle congruence is reflexive, symmetric, and transitive. We've seen those words before, but now with angles. So when I'm talking about angles being reflexive, think about for a second for what that looked like when things were reflexive. What is that going to look like, Mrs.
Well,
Palermo?
before we would say like something is equal itself.
Right.
But since we're talking about congruence, so I'm going to say, let's say, maybe can I say angle A is congruent to angle A, so congruent to itself.
Wonderful. So that idea of just either equal to itself if it was an equality property, but now that it's congruent to itself. Now, what about symmetric?
Well, symmetric's that rewriting. So I would say if angle A is congruent to angle B, so a different angle, then I can say angle B is congruent to angle A. Just kind of rewriting it.
Perfect. Okay, and then what about transitive? That's the one we use a lot.
Yeah, that's the one we should feel pretty comfortable with. So I'm going to say if angle A is congruent to angle B, so kind of sticking with what I'm at. But I got to come up with another congruent thing. And I'm going to say angle B is congruent to angle C. So that then means angle A is congruent to angle C.
Wonderful. Again, if 2 things are congruent to the exact same thing, they're going to be congruent to each other. We have one other theorem that we're going to talk about, and it's that right angle congruence theorem. And this is one of those that everybody goes, oh, I love this theorem, because we hate having to first state that, yes, if they're, right angles, then what does that mean? And going on from there. So this is just allowing us to say that all right angles are congruent. So if I have 2 things marked as right angles, and we've been told that they're right angles, not just perpendicular, but right angles, then we can state that, yes, they are congruent to each other without having to first say, oh, then they equal 90, and then they equal each other, and then they're congruent.
It's kind of, I think that's what's nice about theorems. It allows you to kind of bypass some of the steps that we're used to.
Exactly. So like in the past, we would have had to have say that if angle 1 and angle 2
are right angles.
And that was given to us. We would have first had to have stated that meant that they were what?
Each measures are 90. So I'd have to say angle 1's measure is 90, and then angle 2's measure is 90. And that was because of the definition of right angle.
Okay, and then after I said that their measures were both 90, I would have had to have before stated that then
that their measures are equal, so it'd be measure of angle 1 is equal to measure of angle 2.
And that reason would have been
because could use transitive or substitution.
Either one.
Because again, transitive works for equality and congruence.
And then after I said that their measures were equal, then I could state that they were
congruent. So angle 1 is congruent to angle 2 because of the definition of congruence. So what you're saying, Mrs. Hochgraby, is because of this theorem, it allows you to go from the first thing that you had.
So from this given, I
can bypass those and go straight there because of the right angle congruence theorem.
Yeah, and I'm going to abbreviate. Right angle congruence theorem. You're going to notice that we'll abbreviate a lot of these when we have symbols in math that we can use. For example, angle. Always use that angle symbol, congruence. Don't write it out. Don't take the time to write it out. We're going to just use those symbols in their place.
I like that you abbreviated though.
Yes. It is
Again,
nice to have
going back, don't use the number. Use either the full name, or you can use the abbreviations, or you could just say, as a reason, you could just say all right angles are congruent. Because it's a short theorem, so if you don't remember the name, no worries, just write out what it means.
Exactly.
All right, so we've learned 2 theorems so far. We actually have some more in this section, but before we do that, let's just try an example.
Okay.
All right, so notice first of all in this example that we don't have a picture. So if there's no picture, that means it's really not going to obviously be helpful to us. So we're just going to we only can feed off the given and keep in mind where we're proving.
Okay.
So I can't label anything. So I'm just going to start writing down the given, and I want you to kind of keep in mind what's going on and where you're going.
Okay, so I know that we have 2 sets of supplements, and one, I'm looking at the other part of the given, angle 1 is congruent to angle 4, so that I'm looking at that, and I notice that there's a 1 and a 4 in the other part of the given, and I'm trying to talk about how 2 and 3 are congruent. Okay, well, you know, a lot of times we look for some given things that can kind of help us out here. There's one more given step.
Sorry.
That's all right.
I got ahead of myself. I was listening to you, and I'll just add that up here. Sorry.
Perfect. Okay. So I see that there's a 1 and a 4 up in those supplementary statements. Can I, if I just turned 1 and 4 into an equality, could I substitute them in?
Can I just substitute 4 and 4 right now?
Yeah, can I?
Well, when can we substitute, Mrs. Hochgraby?
Oh, wait, only with equations.
Okay, so this is not an equation. This is not an equation. And this is not an equation. So we can't do any substituting.
Okay. So,
and that's a common error. A lot of times people
Very
want to
common.
just replace. All right, let's just make this go in here. So only thing we can think about is there's no picture. So let's just take one piece of the given at a time.
Okay.
So let's just start with the first part. If they give you angle 1 and angle 2 are supplements, what does that basically mean?
That means that their measures add together to equal 180 degrees.
So I could go ahead and say the measure of
angle 1 plus the measure of angle 2 equals 180. And we have to say measure of those angles, not just that the angles add to equal 180, because that would be talking about their pictures don't add.
Now,
it's measures that add.
Why is this?
That is the definition of supplementary.
Yep. If you look it up, it says angles that are supplementary, they add up to 180. Now, so that we use this first part of the given.
Can I do the same thing with the next part?
Well, we're saying, good
Same
question.
thing.
They're saying angle 3 and angle 4 are supplements, which essentially means they add up to 180, right?
Okay.
So I could go ahead and say the measure of angle 3 plus the measure of angle 4 also equals, that adds up to 180. Same reason, right?
Same reason, and they don't depend on each other.
All right, so I use those two.
Okay.
Still have this part of the given, and I also have what I have in step 2. So keep that in the back of your mind and where you're going.
Okay. Okay, so I'm looking at this and I'm seeing that, first of all, angle 1 is congruent to angle 4. That's congruence. Everything else seems to be equality in this proof. So far, I know I'm supposed to prove something that's going to be congruent, but I know that I can't work with congruence when I've got multiple steps in an equation. So let's go ahead and let's say the measure of angle 1 equals the measure of angle 4.
And again, going off what Mrs. Hochgraby is saying, even though we're sticking with congruence in the end, these addition equations, you can't convert these to congruence. So this would make more sense to switch this over. So if they're congruent, they're equal. So we use that. What's my reason?
That would be definition of congruence.
So I've used everything in the given.
Okay.
And now we got steps 2 and 3 to work with.
Okay. Well, I'm looking at step 3, and I could do some substitution. But they don't quite look exactly the same yet, even with some substitution. But let's go ahead and let's do that for one of them, just to write that statement. Let's go back up to the very first statement in 2. I have measure of angle 1 plus the measure of angle 2 equals 180. Let's make it the measure of angle 4.
So replace angle 4
for angle 1.
Angle 1. All right.
Okay, so measure of angle 4 plus the measure of angle 2 equals 180.
And that was substitution?
That was substitution. But I'm looking at what I have now for that other step in step 2 that I haven't used.
Okay, so we used that. We still haven't used that. We have used that. So these are the 2 that we haven't used. I'm going to star that.
Okay. And they still aren't exactly the same. Ooh, but they both equal the 180. So when they equal the same thing, they do equal each other, right?
Okay.
So let's state that the measure of angle 3 plus the measure of angle 4 is equal to the measure of angle 4 plus the measure of angle 2. Oh, okay. I think I'm starting to see it. So now that I've said that and that would be, I would say transitive property on this because that's how I like it. But I think we could say substitution because we are inequality and it's still, I could take that whole chunk.
Yeah, technically
Replace.
you could say this and replace it in for 180. Either way works. Okay, so let's backtrack. We've used basically everything up to step 5.
Okay, but I'm starting to see it now.
You are.
Because
Good.
I noticed that on both sides of that equation, I have the measure of angle 4.
Ah.
So I could subtract the measure of angle 4 from both sides and say that just the measure of angle 3 equals the measure of angle 2
And my reason?
is SPO, subtraction property of equality.
All right.
Okay, now, I'm supposed to prove them to be congruent, but I can state that from an equation. I can turn that into congruence and say angle 3 is congruent to angle 2.
And reason?
And that would be because of definition of congruence. Oh, man, and I ended up with them backwards, so I can use that symmetric property to flop them
Perfect.
around.
Excellent idea. So this would be angle 2 is congruent to angle 3 because of
Symmetric property.
symmetric. So this last step may not actually happen for some of you if you do this proof. If you kind of notice before, it would have been this step, but that's why the symmetric property is there.
Exactly.
Now, that proof's kind of lengthy.
That is really long.
Took us a while. So I'm praying that there is a shorter way of doing this.
Ooh, maybe there's a theorem.
Maybe there's a theorem. Let's take a look.
Because those theorems make some nice shortcuts.
And before we do anything, I want you to just take notice, because Ms. Hograbe even said this. Notice that in the given, how you're given 2 sets of supplementary angles.
Okay.
And you're also given a pair of congruent angles. And she was making a comment, in that pair of congruent angles, it's involved in the pair of supplementary angles.
Okay.
And notice the 2 angles that are not stated in the given about being congruent are the ones you're trying to prove congruent.
Perfect.
So, just to give you an idea.
All right. So the idea of the congruent supplements theorem, there is a theorem for this,
Yay!
and it shortens it way up. The whole idea of the congruent supplements theorem, and we'll abbreviate it with just congruent supplements theorem. Nice and short.
I like it.
Says that if 2 angles are supplementary to either the same angle or to congruent angles. So we have 2 angles that are supplementary, being the key word, congruent supplements, makes sense. So 2 angles are supplementary to either the same angle or to congruent angles, then they are congruent. Now, I want you to think about this with me, Mrs. Palermo, and see if this kind of makes sense of this theorem. We're saying here that I've got 2 angles, so angle 1 and angle 2. So I've got my angle 1 and angle 2 here. That they are going to be supplementary to the same angle in this first example. Okay, let's think back for a second to what we learned with our special angle pairs.
Yeah.
Okay, when we talked about 2 angles being supplementary, this one is not drawn that way. But if I had made them adjacent, what would they be forming?
A linear pair.
A linear pair. And I'm just going to draw the adjacent ones so that way you guys can see it too. So this is like saying angle 1, angle 2, and angle 3. So these would be a linear pair. And if these 2 had been adjacent, they would also form
A linear pair.
So here I've got an example where I've got 2 angles that are supplementary to the exact same angle. Well, when we had those special angle pairs, when they were all adjacent, what did we notice about these 2 angles?
They ended up being congruent.
They were congruent. And if you think about it, if we just gave some angle measurements to this too, which again, we found those vertical angles to be congruent. Notice this picture, they're not all adjacent. And they don't always have to be. But if I just say that this was maybe 100 degrees, and this one was...
that would have to be 80 because they're supplementary.
Exactly. Then if these are also supplementary, this would also have to be
80.
80. Again, another way to see it. So they can be adjacent, they can be non-adjacent. That doesn't matter. What matters, though, is this whole idea of if they are supplementary to the exact same angle, then they have to be congruent to each other.
So you have to be given 2 sets of supplementary angles before you can say congruent. So like when I read the title congruent supplements theorem,
Yes.
the congruent in that name is not saying you're given congruent angles necessarily. You're given the supplementary angles, and then you're going to be able to prove congruent. Okay.
Exactly.
So this theorem isn't going to prove supplementary angles. then.
This theorem does not. It's given supplementary angles, we can prove some congruent
Okay.
statements.
Okay.
Okay. Now, this other kind of scenario with this one is just saying that if I have two sets of supplements, but they're not supplementary to the exact same angle, but they're supplementary to congruent angles. So notice here, I had to be given two sets of supplements, but they had to have something in common.
Okay.
Here I've got two sets of supplements, but they have nothing in common. But I also have to be given one more piece. I have to be given that one of those sets of angles are the same measures, are congruent to each other.
Okay.
So now if I know that angle 4 is congruent to angle 7, let's think of just in terms of numbers for a second to make sure that this is clicking in our heads. So this is saying that if I had said that angle 7 was our 100 degrees, then if angle 5 was its supplement, that would have to be...
Angle 7 and 6 are supplementary.
Oh, thank you for catching that. Sorry,
So-
4 and 5 are.
That's okay. So then angle 6 would be 80.
80. And if angle 4 was 100 degrees, because these have to be congruent,
That would be
then
given.
this would
yeah.
have to also
That'd
be
80, which
80.
makes 5 and 6 congruent. Those angles congruent.
and that's what we were trying to get to. We're
Okay.
showing that.
Okay.
So again, if you have two sets of supplementary angles, what we need to just notice right away is, are one of those sets of angles common in both, to where we could talk about then these two angles would have to be congruent. Or if we're given two sets of supplements, we have to then look to see, do we know something else about one of those sets of angles? Because if you know that you have another piece of information that those angles are congruent, then it's just like the other one saying that then these are the same, so therefore those are congruent to each other.
So to me, this theorem, it seems a little more not as obvious. I mean, I see like how you're explaining it, but what if for some reason I forget this theorem? Is there
okay.
still a way to do it?
Sure, we just did it.
Oh, so that was kind of a proof of that theorem.
That's a proof of this
So
theorem.
if I do want to try to understand this theorem, which might be a good option, right?
Right, because it's going to save you some steps.
So you would be able to go from step 1.
Step
since you're
1.
given two sets of supplementary angles, and you're given a pair of congruent angles. Since those are congruent, we could go straight to the proof
Exactly. We could say...
and just say congruent supplements theorem.
Uh-huh.
I kind of like that a
It's
little
a
bit
nice
better.
theorem. But again, if you do forget these theorems, keep in mind that the theorems are all proven, so we can do the proofs of those theorems instead.
All right, so now that we have the congruent supplements theorem, there's actually a very similar theorem to the congruent complements theorem. So I'm not going to explain this as much in detail. Ms. Hokeray, we did a really good job with the congruent supplements theorem, but it's a very similar theorem. The only words that are going to change basically is the word complementary versus supplementary.
Okay.
So again, two scenarios. You're going to have either two angles are complementary. You're always going to have pairs of complementary angles. Two
So
pairs.
if I only have one set of complementary, I can never use this,
No.
right? It has
Just
to
like
be
the
two
supplements,
sets.
you got to have, notice you have to have two sets of complementary angles right away, okay? That's usually the red flag. That to me that's when I go to this theorem. So you have two angles that are complementary either to the same angle or to the congruent angles.
Okay.
So we got our two scenarios. Then what you can prove is the two angles are congruent. So you're starting with complementary angles and you're proving congruent. All right, with the same angle scenario, if I give you angle 1 and angle 2 are complementary, which means we know they add up to 90, but we don't need to show that, and angle 2 and 3 are complementary, so kind of like Mrs. Hokeray did here. So let's say this is 20 degrees. Well, then angle 2 has to be
70.
And if I know angle 2 and 3 are complementary, that means this is also 20, which makes these congruent, which is what we can prove. And again, the congruent complements theorem works for, well, let's say you have two sets of complementary angles. Notice they don't have any same angles, but they do have a pair of congruent angles. All right? So angle 4 is complementary 5, angle 7 is complementary angle 6, and they have these common congruent angles. All right, so that would make the remaining two angles congruent as well. All right, again, we could substitute some numbers in if we wanted. So let's say this is 30 degrees. Well, that would make angle 5.
60.
And we know since angle 4 and angle 7 are congruent, that means angle 7, is 30, which means angle 6 is
Also 60.
which makes these congruent, which is what you can prove.
Perfect.
All right, again, stressing the fact with these congruent complements and supplements theorem, you have to be given 2 sets of complementary or 2 sets of supplementary angles before you can do anything.
Right.